everyone, this video will, I suppose, recap all of the case studies that you need to sit paper 1 of your GCSE exam. Paper 1 of your GCSE exam, for those of you that have forgotten, is all of your physical topics. So this would be your natural hazards, your living world, and your physical landscapes unit. Remember that physical landscapes unit's broken down to 3 sections. So it has coasts, it has rivers. We haven't studied glaciers, so you'll notice I've crossed it out here. So there are no glaciers case studies to learn. Similarly, in living world, you would either choose to do a cold environment or a hot environment. We've obviously chosen to study a cold environment, so there'll be no hot environments case study in this video, quite simply because you don't need to learn one. So this video will go through every single one in order and do like a bit of a brief overview. If you want more detail on each one, there are individual videos for every single one of these case studies. You just need to go back and probably search through to find them, but they do exist. So your first case study is of an LIC earthquake. So the case study we've done of an earthquake in a low-income country would be the Gcse earthquake in Nepal back in 2015. This is a 7.8 magnitude earthquake, so it's pretty significant. This one is the one that had quite a few large effects. So you've got 8,841 people that have died. You've got 50% of schools completely destroyed. One of the most significant primary effects is this one here that I'm highlighting. So 352 aftershocks, including a second 7.3 magnitude earthquake. So the second earthquake that they have is almost as big as the first. The big problem with this is that they didn't really have much time to recover. They didn't really have much time to prepare. And a lot of the area is already significantly damaged, but then it gets damaged further by the second earthquake. Cost of the damage is pretty impressive. It's $5 billion US. So the big one with this as well is you haven't just got the damage from the initial quake, it also does cause an avalanche at Everest, and the base camp there is also destroyed. So you've got, yes, people dying from the earthquake, but you've also got 19 people that die, unfortunately, from the avalanche there. Note the difference here between primary and secondary effects. So primary are things that happen straight away. Secondary are things that happen as a consequence of something else. So you have to know how Gcse or Nepal has responded to this. So similarly with primary and secondary, you have short and long-term responses. Short-term responses are things they do straight away. Long-term responses are things they do a little bit later on. So in the short term, they've got things like temporary shelters. One of the most impressive things, perhaps, is that Facebook launched this safety feature. So essentially, people could log into social media and mark themselves as safe. So family members, etc., were looking for them. That was quite a good tool. Long-term responses, they had loads of aid that was committed in 8 months after the earthquake. The big critique of this is how they've really spent it. I mean, have they spent it? Or what's the government doing with that money is a question that quite a few geographers are asking. So yep, loads of aid has been pledged, which is amazing, but has it actually been spent yet? That's your big critique, that's your AO3, that's your evaluation in the exam. So if we contrast this LIC earthquake, you've got to have a HIC example, so a higher income country example. Tohoku in Japan in 2011 is your big contrasting earthquake here. This earthquake is slightly bigger. So it's a 9 magnitude earthquake. It happened just off the coast. Obviously, if an earthquake happens underwater, there's a huge chance that we're going to get a tsunami, and we do in this case. If you look at the amount of damage here, so it cost way more than the Gcse one. This one here is costing somewhere in the region of $14.5 to $34.6 billion worth of damage. You've then got significant amount of buildings and roads destroyed again, and you've got 22,000 people estimated to have died here as well. So you might say, well, if I compare that to the LIC one, these effects are far more greater. And you could argue that that's the case, that because this is a HIC, it's happened in a city, you'd expect there to be more people. You'd expect if it's a HIC, a greater level of development, and therefore it would cost more as well, perhaps. So secondary effects, or things that happen later. You've got the tsunami, as we sort of alluded to earlier on. You've got the potential for nuclear accidents. You've got parts of the UK, so Sunderland, for example, that are being affected because of the parts shortage. The factories have been some damage to, so therefore they can't ship the parts across that we need. So you could argue, or to some extent the effects here are far more wider reaching because actually in the UK we've been impacted. Short and long term responses again, so they've evacuated 140,000 residents. You've got 55 nuclear reactors taken offline, obviously for safety reasons. In the long term then, you've obviously got that damage, as we said, to car plants in the UK. You've got the fishing industry that's operating at just 20% of its previous capacity 6 months later. So you might argue, yep, they seem to be back up and running pretty quickly, but they're not obviously back up and running at full speed, are they? So there's your sort of big contrast again to Nepal. Also within hazards then, you need a case study of a tropical storm. So the one that we have studied is Haiyan. In this one here, I've just put the numbers to the side. I suppose my big tip with case studies is I wouldn't say learn any more than sort of 5 points a case study, because you've got to think realistic here. You've got like 10 or 11 that you've got to learn for this topic. So play the long game and just think really smart about what it is you need. With my classes, I always talk about sort of the key ones and key things I would learn. So the what, the why, the when, the how. And as long as you've got a case study point for each one of those, I think you would have enough covered in the exam. So back to this one here, you've got 6,190 people that have died. You've got over 1 million farmers that are affected. This has happened in the Philippines. So for those of you that have forgotten, we're talking Southeast Asia here. Essentially, the typhoon starts over the Pacific Ocean and travels right the way through the centre of the country. This is why it's caused so much damage here. So we have a mix of primary and secondary effects. So I suppose if we go for the big primary effects, you can obviously pause and read this in a bit more if you wanted to. You've got a Category 5 typhoon, so the most serious one you can get. You've got winds up to 314 kilometres an hour. You've got damage to the airport, 400 millimetres of rainfall here, and it's cost, the damage to farming here, $53 million. Secondary effects, you've got 800,000 litres of oil that are leaking into the water here. You've got 8 deaths due to stampedes, so people now starting to panic. An 11.9% rise in the price of rice, so pretty significant effects just for a tropical storm. So if we think about how they're managing this then, what we've got here is the president issuing a warning on television, so this happened immediately. They evacuated 800,000 people, they delivered 1 million food packs, and the long-term response was to launch this Build Back Better scheme. In theory, the government now have got some building regulations in place, and for everybody that wants to build or develop, they need to follow these. The big problem is here, I suppose, they're not really enforced that particularly well. So you might argue, well, if you're not enforcing it, what's really the point in having this Build Back Better scheme? So if we contrast that with an example from the UK, we did Beast from the East, which happened in 2018. Again, all this is an example of an extreme weather event. Why do you need to know this? You need to know how an extreme weather event impacted on the UK. So this is the one that started in 2018. It was the 22nd of February when this happened. Essentially, it was an anticyclone. So we had really high pressure, cold temperatures, clear skies. And if you look at the map that you can see on the screen here, you can see that it pretty much affected areas across England, Wales and Scotland. So essentially, you might argue, well, why do I really need to know this? You've got to know impacts and you've got to know management of this one. So impacts I've grouped by social, economic and environmental. Socially, you've got 10 people that have died. You've got temperatures in the countryside that went down to -12. You've got people that were stuck up in Glasgow for up to 13 hours. Rail services cancelled. Shortage of food in some supermarkets. Our travel and economy was impacted as well. So you've got British Airways cancelling lots of short-haul flights. Businesses without power. But the environmental impacts, I think, are quite significant. So wind speeds greater than 70 miles an hour, 50 centimetres of snowfall. That's pretty impressive. So how are they managing this? We had red weather warnings. The Environment Agency issued flood warnings. We've got the RAF that are here now transporting doctors. Military providing support, rescuing people. We had soldiers that were deployed to help in hospitals. So we're talking a pretty significant event, obviously not on the same scale as Haiyan, but for us in the UK, it was pretty important, and we marked the day. So we can also compare this then with another extreme weather event that happened. Some of you might have studied the Cumbrian floods. These happened in northwest England. Essentially, you've got the river here that floods and how it impacts on the local town was this case study. So you've got record heavy rainfall here for 36 hours, a month's worth of rainfall before the event. So the soil is already really saturated and it's left the water flowing 25 times faster than usual. So this has caused us some impacts. Again, these are grouped for you, but you've got essentially one dead. You've got the police officer that gets killed when the bridge in the town collapses. You've got 1,500 homes that are flooded. You've got 6 important bridges that are destroyed by the debris, so transport in the town is really well hit. Environmentally, you've got landslides, you've got hundreds of trees washed away, so you've got significant damage to habitats. If we think about how we're going to manage this, they've built some brand new flood defences which cost them £4.5 million. It's funded by the government and the local community. You have got some improved warning systems, so they're now sending alerts via text message should something similar happen in the future. They've also laid some agency for local businesses to try and help them get back and open for business as usual. So moving on to the second sort of chapter in the paper, which would all be on ecosystems. Your first big case of an ecosystem is Epping Forest. Epping Forest is an example of a small-scale ecosystem within the UK. We're just looking here to see about relationships and how different organisms, etc., rely on each other and look for real-life examples. So Epping Forest does that really well for us. The food web here that you can see on the screen shows you how this sort of interdependence works. If something is interdependent, it means it relies on something else. So you might say here, well, for example, the fox is interdependent with the rabbit because it relies on itself within the food web. You might argue that most of these organisms here are interdependent on the insects, and without those they might cease to exist. You've got really high biodiversity here. So for example, you've got a variety of trees, you've got 177 species of moss, 700 species of fungi. So if you're asked how a small-scale ecosystem in the UK shows biodiversity, here are basically your big key points that you would want to use. This is also another brilliant opportunity to talk about nutrient cycling. I talk about this quite a lot in my Epping Forest video, but just as a quick recap, I always think the best way to think about nutrient cycle is to think about the life cycle of a tree. At biomass here is where your lovely big tree would be. Come autumn, this tree loses all of its leaves. So this is how we get to the litter phase. These leaves then mulch down into the soil, and that's how we get back to here at the end. And the tree at biomass takes up all of these nutrients from the soil to grow again into that lovely big tree. You've got some inputs here. So obviously our ecosystem's constantly changing. So you've got some precipitation, so rain being added, which helps to mulch down those leaves. You've got little bits of rock in the soil, which help to improve soil quality. So that's being added here. But at the same time, with heavy rain comes runoff, so some of this water is lost. And also comes leaching. So we do lose some of these nutrients from the soil as well through other natural processes. I would just check that you can explain the nutrient cycle. I've seen it come up a few times before where you've been asked to outline this for 4 or 6 marks. So it's definitely something just to have in your back pocket and to make sure that you can do. Your other big case study in this unit is the Indonesian rainforest. What do you need to know? You basically need to know the causes and impacts of deforestation. Indonesia is located in Southeast Asia. It's got one of the largest expanses of rainforest. Back in the 60s, you had approximately 80% of Indonesia that was covered in rainforest. That's why it's so special. That's why we studied it. There are big causes of deforestation here. So you've got subsistence farming, so where people rely on the land to grow their own food. So the local community here are partly responsible for deforestation by chopping down some of these trees in order to be able to grow their own produce. You've got commercial farming, so those people that do it on a much bigger scale. Again, you've got people here that are chopping down areas of the rainforest to produce goods which then go on to sell. So palm oil is the biggest one for this. Logging, so chopping down the trees and using this wood, so taking it to sawmills, etc. for things like, building infrastructure or building property. You've got road building, so again, destroying some of the trees here and using that area, therefore, to build roads, so to improve transport connections within Indonesia. It continues. Mineral extraction, so some of your most precious stone is found within the rainforest. So of course you would need to remove the trees, I say of course, but you would need to remove the trees in order to be able to get to that. Energy development, so again, Indonesia relies heavily on fossil fuels but sometimes has the potential then to use renewable sources, so they are removing parts of the forest in order to be able to explore this. Settlement and population growth, I think, sort of go hand in hand together. As the population continues to grow, they are needing to destroy more of the rainforest in order to be able to accommodate those people and to make space for brand new housing developments. So that's sort of the why and the first part, the causes. So why have we got lots of deforestation within Indonesia? It's those 8 reasons there. How does this impact then on Indonesia? Well, it's impacting again on their economic growth. So currently agriculture is contributing to 14.43% of Indonesia's GDP. I think that's pretty significant. 41% of the workforce is employed in agriculture. So it's all well and good now saying, right, we need to sustainably manage this and we need to help. But if you've got 41% of the workforce employed in agriculture and needing that space, then you're going to have to help, aren't you, with employment and finding them some sort of alternative here. It's causing soil erosion. The tree roots essentially hold all the soil together. So if you remove the trees, it makes it much easier for heavy rains, as you would expect in the rainforest, to wash away some of the soil. Obviously, the big one would be climate change. 300 billion tonnes of carbon here are stored in the trees. So obviously by taking those out, it's going to contribute. And loss of biodiversity as well. So only 20% of the forest is protected. So you might argue, well, from a sustainable management point of view, we would need to increase the amount of rainforest that's protected if we're to sort of see any big impacts here. Now, as I said at the start, we are going to do a cold environment. We're not going to do hot environments. That's just a choice that we've made on the paper. And so if you see any questions that ask you about hot environments, you're obviously going to write about cold environments. It will say that in bold at the top. It's on either or normally. So your big case study here is Alaska. You need to know development, opportunities and challenges. Opportunities, as I always say, is like the good things. Challenges are like the drawbacks or the limitations. So your big opportunities here are the fact that commercial fishing employs 1 in 10 Alaskans. Some of these jobs are seasonal. You've got some opportunities in mineral extraction. So 1/5 of the state's wealth comes from gold. It's contributed $2.2 billion to Alaska's GDP. Energy is pretty significant. So over half of Alaska's income comes from the oil and gas industry, and 90% of tax comes from that as well. Tourism, so you've got tourists that are attracted to this area, which is fantastic. Again, you've got 2 million tourists each year that are bringing in money. So you might argue that, wow, there's sort of a wealth of opportunities for what seems like a pretty remote environment, and you would be correct in thinking that. So these are all really positive things. However, with the positive does come some downsides, and there are some challenges. So the first challenge would be extreme temperatures. So it goes down in the bay to about -9. You've got a lack of sunlight, which sometimes makes it quite hard to develop. So you might say, well, if you've got lack of sunlight and really cold temperatures, is this the best place to be developing? That's sort of a limitation and obviously puts some people off. You've got inaccessibility. So it's a long way from the rest of the USA. It's quite expensive to access. You've got permafrost, which makes it a bit of a challenge to develop. A low population density, so less than 1 person per square kilometre. Buildings and infrastructure then links in, I think, quite nicely to this inaccessibility. So construction work can only take place during the summer. This is because you haven't got enough daylight essentially for the rest of the year round. So you might argue, well, that limits some of the development if you can only develop in a small portion of the year. If you've got permafrost, so permafrost is the state of the ground being permanently frozen, but obviously in the summer with the sun it would melt. So this does cause some of the buildings to sink into the ground. So now if you're building, you've got to put your buildings on stilts essentially to stop them from sinking into the ground. Airport runways are painted white to reflect the sunlight as well. So yes, we've said there are huge positives, but also you've got to balance that now with those challenges we just talked about, and which do you think is most significant? That's most likely what they're going to ask you in the exam. Okay, moving on to the final section then, if we start with coasts, you've got Dorset coastline. This is your example of a section of coastline in the UK, which basically you need to know its major landforms. I won't explain all of these because I've done this previously in other videos, so this is just a whistle-stop tour. So essentially if we work left to right on the map then that we've got here, you first and foremost have got Durdle Door. Durdle Door is a famous example of an arch. Eventually, if we fast forward the clock, however sad it is on Durdle Door, this top part here of the arch will collapse and it will leave behind a stump. If I sort of move further east then along the coastline, next I'm at Lulworth Cove. Lulworth Cove is a famous example here of a bay. This one is very different to the other one we're going to look at in a minute, but this one here is formed because this is a concordant coastline. So we've got different layers of geology that are set back from the coast, so they're lying parallel. So next, if I move to Kimmeridge Bay, again further east along the coastline, I've got another example here of headlands and bays. These are formed due to differential erosion, so you've got bands of hard and soft rock, and the soft rock retreats much quicker than the hard rock. But most importantly, and my favourite one I guess I would say, is Old Harry's Rocks. So these are a brilliant example here of caves, arches, stacks and stumps. So I suppose you get to see the full journey then of all three features that we've talked about already, sort of exemplified in one big key place. Old Harry's wife is the stump who sort of sunk into the sea. Old Harry is the stack that is left behind and the bit that's sort of sticking out into the ocean. You've got your little arches and your caves, etc. So in the exam, if you were asked to explain the formation of caves, arches, stacks and stumps, this is the case study here or the example that you would be using. You do, however, also need to know about a coastal management scheme in the UK. So we know these environments are changing because we've just seen that with places like Old Harry's Rocks and caves, arches, stacks and stumps. And so Pevensey Bay is in East Sussex, it's on the southeast of England, and it's an area that needs managing. The beach here is being removed quite a lot by longshore drift. You've got 50 kilometres squared of land that's going to be flooded if we don't protect it. It's a triple SI site, so that means it's a site of specialist importance. It's got lots of species, so plants and animals, but you've also got people that are living there as well. And so if we do nothing, which is the big dilemma at the moment, you're going to lose some of your tourism, transport links are going to be destroyed, and you've got 10,000 properties as well that are also under threat. So they've done three things here to try and manage Pevensey Bay. They've done a bit of beach reprofiling. So they've taken some of the material in winter that's been moved down the beach, and the bulldozers sort of drag it back in to create a nice gentle slope on the beach to try and take some of the power out of the waves. You've got beach replenishment. So we're constantly losing material on the beach, and we know that because we've got processes like longshore drift and transportation. And so they dredge the seabed and they spray that material all the way back onto the beach. So if you like, the cycle almost starts again. It's not a permanent fix. And then you've got beach recycling as well. So we know because of longshore drift, the material gets moved west to east. And so they get trucks in about 3 times a year, I think it is. And they take all the material from the east side of the beach, put it on the lorry, drive it all the way back to the west and dump it there. So the process starts again. So this does have some effects. The big effects here, I suppose, and the obvious one is that they're all soft engineering techniques. So it does require a lot of maintenance. However, it's a lot cheaper to do. If you've got a really nice maintained beach, it's going to attract lots of tourists. So you might say, well, it helps the local residents keep their source of income. The conflicts here is so far they spent 75 million on it. So it's extremely expensive. The residents are pretty angry. They don't particularly like the soft engineering because they don't think it's doing enough to protect the local area. So they're not particularly happy. However, the Environment Agency also agree with them, and they're saying, right, I think we need a seawall now to try and help protect some of the plants that are behind it. So essentially you've got the local residents and the Environment Agency that are joining force here and saying, we want more. And so your final section would obviously be on rivers. So we've done the River Tees. It's an example of a river valley then that shows its major landforms. Remember, the river gets broken down into 3 courses. You've got your upper course closest to the source, your middle course and your lower course. In the upper course here, you've got a V-shaped valley. It's got a 20-metre drop. I think it's about 5 metres wide off the top of my head. You would expect to see your waterfall here. High Force is your example of a waterfall on the course of the River Tees. It's got a plunge pool. There's a steep-sided gorge there as well. In the middle course, if you look at the map here, you can see them, are your Darlington meanders. These are the ones that eventually will lead to Oxbow Lakes. So check you can explain meanders and Oxbow Lakes because Darlington meanders is your case study to use there. In the lower course, this is where the River Tees meets the North Sea, so it's not too far from Middlesbrough at all. So here you've got your estuary, so that's there. You've also got then your Teesside oil terminal. So it's got a channel width of about 500 metres. It's about 2 kilometres wide. So this is where you've got all of your ships coming in. So yes, you've got an estuary, but you've also got lots of human activity here as well at the point where the river sort of meets the coast. So last but not least, we're really pleased to know is Boscastle. So a bit like you had a coastal management scheme, you also need a flood management scheme, and that's what Boscastle is. Boscastle was a village that's located on the north coast of Cornwall, so we're talking southwest England here. It's really vulnerable to flooding. The catchment area here is pretty small. It's got lots of impermeable rock. Essentially, you've got a few small businesses and homes that are located towards the bottom of a valley. And so therefore you're going to expect some flooding, unfortunately. They've launched a flood management scheme after 2004. They had quite a lot of rainfall that fell pretty quickly, and it damaged and flooded a lot of the buildings there at the bottom of the valley. So they've done a few bits and bobs. They've done some hard and some soft engineering. Soft engineering is typically natural and it's low impact. You've got hard engineering that's obviously a bit more man-made, so think things like lots of concrete, for example. They've basically built a flood wall. They've put some embankments in along the river. They've dredged the river a little bit to make it a bit wider and a bit deeper so it can carry more water. Soft engineering wise, they've got rid of the dead trees. They've raised the car park. They've put in a new gauge so they can monitor the flow of the water, and essentially have some sort of flood prediction and flood management and give people a bit more warning this time to get out. So with this, it's created social, economic and environmental issues. So socially, you might say, right, people now have got more time to protect their properties. Possessions can be saved. So you might say, well, that's a good thing. Economically, it's cost them £4.6 million. More expensive buildings are further away from the river. So you might say that's quite good, actually, if they put more expensive buildings away from the river because it's reducing their flood risk. Environmentally, you can't really change land use. Once it's already built and developed, you can't really move those things. So you've got to mitigate around it. You've got landowners now that are being encouraged to sort of maintain vegetation and plant new trees because all of that helps to intercept and soak up some of that water in the event of a flood. So you might say, yep, they've got quite a few large-scale things here and they've done quite a lot for the river, but they're also helping to encourage that local community as well. And so you might say, well, here's a really good example of when help from the government goes hand in hand with the local community. And so that is a very brief whistle-stop tour, I suppose, of all of your case studies that are on the physical paper, the first paper that you sit. As I said at the start, please don't learn any that are to do with glaciers. We're not answering questions on that. Please also don't learn anything on hot environments because we've chosen to study cold environments.